Hello everyone, welcome back to the channel. Now in today's video we are going to learn a new data structure, that is hash table, right? So we'll be understanding what this data structure is all about and how it is useful while solving problems. Okay, so let's get into it. So hash table, as you can see, I have written a data structure that store data in key value pair format. So what do I mean by key value pair format? That means every single value that you're trying to store in the particular data structure, right? It is mapped to a particular key. Okay. And why it is mapped to a particular key? Because whenever you're trying to retrieve data from the data structure, you use that key to retrieve that particular value or object. Okay. That means every single value is paired with a key. Right. That is why it is called a key value pair. So what is a hash table? Hash table is a data structure that is stored data in key value pair format. And hash table is considered the fastest data structure for data retrieval. Now how is it the fastest, right? Now it is fast because of this hash function, right? So what is a hash function? As you can see, a function that gives you a hash value, a value that tells where a particular key is stored in memory. Now let's understand what this hash function is. So as we know that hash table stores data in key value pair format. Store the data in memory, you're not storing it directly, right? The key that you're passing, right, it is going through some logic, and that logic after processing returns some value. Okay, now that particular value is used to find the address where that particular value is going to be stored in memory, right? Now the logic through which this key is being passed, right, and processed to get the value back is called a hash function. Okay, and the value that you're getting out of this logic after processing is called a hashed value, and that hash value is how you know where you're going to store this particular data in the memory. Okay, so hash function is really very important. Now hash functions are deterministic. What do I mean by that? That means if you're passing the same value through your hash function to get the hash value, if you pass the same value, you are going to get the same hashed value as well. That's why it is deterministic. Unless you pass a different value, you are not going to get a different hashed value. Now dictionary is a very good use case for hash table, because whenever you have to do a lookup, right? Now for lookup, hash table is already a wonderful data structure. So you can do fast lookups through hash tables. In databases, there is a concept of indexing. Okay, internally, if you dig deep into the database code and all, which generally people don't do, you will find there also we are utilizing the concept of this hash function and hash table, so that we can do a fast retrieval of the data. Now I hope you got the basic understanding of our hash table. Hash table is a basic data structure that stored data in key value pair format. It is considered fastest data structure for data retrieval. Now concept of hash function is what gives you a hash value that tells us where the value is going to be stored in memory. And we talked about few use cases. Now let's see how hash table is implemented in our Java code base. We'll go through these methods to understand it better. In Java we have a map hierarchy. Let's take a integer as a key and string as a value. Okay, this map is from our collection framework. Now let's create a hash map. Now hash table is actually a legacy implementation. Okay, that's why I'm not using that hash table directly here. In our collection framework we have maps, so I'm going to use hash map instead of that hash table. When we are trying to understand its internal functionality, right, we'll be implementing these methods by ourselves. That is put method, get method, contains method, all these, right? To see how hash table works in Java, I have taken the hash map. New hash map. Now let's try to add few values to the hash map. Hash map dot put. Now see, put method has two arguments. First one is key and the other one is value. Now let's take one. I'm taking one as a key. I'm storing my name as a value. Now let's add three values there. Okay, I can show you one more thing. Let's add one more name here. I can add some shell out there. Let's add one more name. Okay, now I can show you one more thing. Let's try to print it and see what we are getting out of it. Then I'll show you few more operations related to it. Now let's try printing this hash map and see what we are getting there. Okay, so you see we are getting our hash map printed in a key value pair format. One key is mapped to Shubham, two keys mapped to Sherlock, and three keys mapped to John Wick. Okay, so now you see how our map is structured. Now let's try some more methods. Before I try some more methods, I want to show you, if you again replace that same key with some different name. Okay, let's say Tom Cruise. In that way it will just replace the existing key value. You see, you have the key available in your hash map, but it is replaced by the new value that we have provided. So that's just one example of it. Now let's try this remove method. Hash map dot remove. Let's pass 2 as the key, and now try to print our map again. Now if that particular key is removed, we are supposed to get 2. You see, now 2 Sherlock is removed from the hash map and we have 2 key value pairs in our hash map. So that's how remove works. It takes that key and removes that from the hash map. Now let's try that get method. Hash map dot get from the key. Let's try. I'm trying to get value based on this key 1. So on the key 1, as we see that my name is mapped, we are supposed to get my name, and we are getting it. That means it is able to retrieve the value based on the given key. Now the contains key contains value works. It just checks whether that key or value exists in your hash map or not. The only difference is that to check the key, it directly uses our hash function. So this operation, is done in a constant time, that is O of 1. And if you're trying to see if your value exists in the hash table or not, contains value method. Now this method is going to run in linear time, that is O of n. Okay, I think I can show you that just like that. Hash map dot contains key 1, we are supposed to get true. Let's check that value method as well. Contains value. Let's pass value as Sherlock only, the one that we have removed. So for first one we are supposed to get true, and for this one we should get false, and that's how it is. You see, so that's how your contains key and contains value method works. Now entry set, basically so if you want to iterate through your hash map, right, you cannot do it using your for each loop directly. What you have to do, you have to make use of entry set, right? So if you want to iterate through your hash map, right, you make use of something called as entry set. Now how do you do that? Let's take some variable n or map. We want to iterate through hash map. So you cannot directly iterate through your hash map. Okay, you need the entry set from it to iterate. Now how do you iterate there? For each of the value, let's make this as entry. Actually, entry, that sounds better. In the entry set, for each of the entry you want to iterate, and for each entry what you want to do, you want to print, let's say, key and value for them. So entry dot get key and entry dot get value. Let's try printing these and see what we are getting there. We should get 1 Shubham and 3 John Wick. See, 1 Shubham and 3 John Wick. So you saw how, from our Java code we make use of this hash map. We have seen how we can add objects to our hash map. We have seen how we can remove. We have seen how we can check if the value or the key exists in a hash map or not. We have seen how you can retrieve the value from the hash map, and how you can iterate through your hash map to get the individual entries from your hash map. So I think this was enough to give you a introductory concept of hash table. Just remember one thing: hash table are literally one of the fastest data structure in our collection framework for the retrieval operations. Okay, so yeah, I think this was enough for the introduction. We'll be doing some really interesting questions on hash map. You will understand the value that hash map gives you, and later we'll be implementing all these methods by ourselves, just like the same way we are doing with the other data structures. Okay, so just practice this and see you in the next video. May the source be with you.